Okay, welcome to video 3. Today we're going to be talking about writing equations with vertical and horizontal shifts. So in exercise 1, we're going to determine the key point and describe the translation that has applied to this parent function to make w of x equals the square root of x plus 4 minus 2. Well, the first question is, it talks about a parent function. What does a parent function mean? Well, that means that it's the most basic form. So what is the parent function of this if we're looking at the square root of x plus 4, then minus 2? That means the parent function is just plain old square root of x. So the question is, what's the key point here? Well, what happened to the key point? It was at 0, 0. Now it's going to be plus 4, but that we would think would mean positive, but it's the opposite of what we think. So it actually means left 4, which means that it's going to move from 0, 0 back 4 spaces to negative 4. And then we see this minus 2 here. That means that it's moving down 2. So it's the opposite of the inside number, or the one with, under the square root in this case, it could be in parentheses with the x, and then we move up or down. So what translation was that? It was translated left 4 units and down 2 units. What happened to the x value in the equation to make the key point? Well, we already talked about this makes the opposite or inverse of the number that's under the square root with the x. So remember, it's always the opposite for the x. And then what happened to the y value in the equation to make the key point? Well, if we look, we can see that it's the same value, and we have already talked about this a little bit. So this is the same value as the number outside of the square root. So opposite for the x, same for the y. So horizontal and vertical shifts written symbolically using function notation. When we have a horizontal shift, or the x part, the k number inside the parentheses, so we have like an x plus k. It's happening with the x. A vertical shift, or the y part, the k number is outside of the parentheses, so it'd be like the function plus k. So the original is the square root of x, and then the new function would be the square root of x plus 4 minus 2. The translation applied to f of x to get w of x. So if we use this function notation to write this, what would it look like? Well, what we're doing here is we are using w of x. In place of the x in the f of x function, we're putting this x plus 4, so it would be f of x plus 4, and then we have the minus 2 that's happening here. And we'll explore that more as we continue looking at this function notation idea. Okay, in exercise 1, given the function f of x equals absolute value of 3x, if g of x equals f of x minus 2, how is the graph of f of x translated to form the graph of g of x? Well, if we look at this, what's it going to do? Well, in place of the f of x, we're going to put what f of x equals. So it's still a lot of this substitution idea. So I'm going to replace f of x with this absolute value of 3x. So what it would look like is g of x equals the absolute value of 3x and then minus 2. So what happened to this? We look, it's an outside number that's changing, so it's translated down 2. So that's what that tells us, because that minus 2 was an outside number here. Okay, so now if we look at the part B here, if h of x equals f of, now we have x minus 4. So x minus 4, that means that it's replacing with the x value. So if I write this, I'm going to replace the x minus 4 in place of where I used to have an x value to make this h of x function. So if I look here, now we've got something happening with the x. So that means that it's going to be a horizontal movement, and it's the opposite of what we think. So when I say negative 4, I think, okay, well, negatives on the graph go left, but it's the opposite of what we think. So this is actually translated right 4 units. So again, that's just the opposite of what we think. Okay, let's look at exercise 2. The parabola represented by f of x equals x squared minus 4x plus 3 has a vertex. Now this is a little bit different. They're telling us what the vertex is. And we want to find the vertex of a parabola that's defined by this new function. And then we have to explain how we arrived at our answer. Well, if I look, it's starting off at 2, negative 1. And then we look at what's happening in this f of, or g of x function. It's taking f of an x minus 2. So what am I doing to the x value? Well, we would think left 2, but it's actually right 2. So that means that I'm going to add 2 to my function here, to my x value. So we write that by adding the 2, and it becomes 4, negative 1. Okay, and I found my answer by identifying the transformation as translating right 2 units, which would add 2 to the x value. and we'll continue this more in class.